Okay, good afternoon, everyone. So, yesterday we had Maharevision for manufacturing part 1, and today we are going to discuss some questions, good questions, based on whatever we had Maharevision yesterday. Okay, so genius, so you are 𝐂𝐚𝐿𝐴 Sir. Hello, you are here. Sumit Gupta, good afternoon. Lunch done around half an hour back, only lunch done. After that, I have taken, little rest for 10-15 minutes, then I am here. Good to see. Who all are there? Good afternoon. So there are around close to 22-23 questions here. Vrishal, good afternoon. So, all of you know, design is slightly different. Some of you may be knowing. Swastik, Tejas, Annamacharya, Amaname, Mukul, very good afternoon. So I think this you know very well because Maharevision also I briefed it. Now we are going to discuss questions based on material science. Questions on forming, questions on metrology, and questions on casting. Okay, now new template is Lokhande, very good. Okay, Devanarayan, Lavkush, Sumit. Okay, good to see you. So I think this session will last for 1.5 hours only. Evening session there are 35 questions, so that session will be a little more. But this session I have exactly how many? 21 questions. So 1.5 hours, approximately 3:30 we will finish. Okay, very good. So please be attentive, and if there is any question, please chat box is ready. All right. Plastic Gamor N8Q. Good. So this is the schedule. Maharevision, strength of materials IPND, manufacturing process IPND, APND in Telugu it means finished. So tomorrow Panditji will come, Shivam Dikshitji, then our IIT Baba. Manufacturing part, this is the schedule. So as I told you, every teacher worked hard to give best for Maharevision. So please be attentive, it will be a very good revision. Very good. Devara, you please let me know after some time, okay, because some questions are there. I will tell you. Thank you. Devanarayan, thank you. Kushagra, namaskaram. Kushagra is one of our champion. We are expecting if we do bhajans. And this is a Super 20 schedule. Anyway, every alternate day. This is the Mahabhyas, 7 p.m. This is already over. This is Iroju. Means today. Okay? Good afternoon. All right. So Telegram group, as I told you, the design is little more attractive. This template, I liked it actually, multicolor. Okay, so every Sunday at 5 p.m. I am live here. So whenever you have any confusion, then you please really I liked it because regular lecture this is the best multicolor things. I really liked it actually. Malikum assalam, Muhammad Aizam, Mahanda Aizam, very good. So let us start. So my dear students, you please let me know after 5 or 6 questions we will be doing IES, means that crystal directions question. It's a very good question, okay? So Some of you already I have discussed, but still we will do it. Okay, na? All right. Do it. I want you to give me the answer in the chat box. Some of these questions I might have discussed with you during your classes. No matter how easy question is, always make the fit diagram. Always make the fit diagram. A hole and a shaft have a basic size of 25 mm and are to have a clearance fit with a maximum clearance of 0.02 and the minimum clearance is 0.01. So make the fit diagram. Hole basis system means this is the hole tolerance. This is the hole tolerance, and because it's a clearance fit, shaft will appear here. Minimum clearance is 0.01 mm and maximum clearance is 0.02 mm. Always make the fit diagram. Always make the fit diagram first. The hole tolerance is to be 1.5 times the shaft tolerance. Let us say shaft tolerance is x. This will be 1.5x. So this plus this is equals to 0.02. 1.5x plus 0.01 plus x is equals to 0.02. So 2.5x is equals to 0.01. Calculate x. So this is 0.004 and this is 0.006. Now you tell me the answer. Now you tell me the answer. Everybody will tell me in the chat box. Everyone, those who are our main batch student, some of these questions I might have done in the class. But don't worry. Revision of good question is always good. We should do revision of good questions. We should do revision of good questions. Yep. Yeah, very good. Chala bagundi. Very good. So minimum size 25. Maximum size is 25.006, correct? This is the maximum size of shaft and it is 25 minus 0.01 means 24.99. Yum. And this is the minimum size. 25 minus 0.01 minus 0.004. 24.986. Yum. Answer is A. Very good. Yum. Okay, na? See, 50% of you are maybe our classroom students. So some of these questions I might have discussed, but once again, these questions we have to revise it again. Okay, na? So, all right. What about this? Quickly. At the end, I will ask you out of 21, how many questions you did correctly? I will ask each and everyone, how many questions you did correctly out of 21? अमन की आशा. Always draw fit diagram before hitting the answer. So basic size is same. Hole. It's a hole 0.04 and the shaft starts with 0.041. So it's a shaft 0.041. Because 0.041 will be more than 0.04, so the tolerance will be above the hole tolerance, and this is the 0.06. So it's a interference fit. Yeah, most of you are doing really very well, really very well. Most of you are doing really very well. Good, good, good. But some students, this one, go and no go snap gauges are to be designed for shaft. Gauge tolerance can be taken as 5% of the hole tolerance. Following the ISO system, it clearly says it's a ISO system. ISO system. The respective size of go and no go gauges are draw first of all fit diagram. This is a shaft 0.01 and 0.06. Width of tolerance zone is 0.06. Width of tolerance zone is 0.06. Now, if we have to follow ISO, it's a shaft, means it's a plug gauge here. Plug gauge. So, ISO. Width of tolerance zone is less than 0.1 mm. Width of tolerance zone is less than 0.1 mm. So, I will not provide the wear allowance. So, my go will be here, no go will be here. It will be like this. This is 0.06. This will be 0.006. This will be 0.006. That's what it is. Always draw fit diagram before hitting the answers. Always draw fit diagram. Aditya Kothawale, you are, I think, 5 minutes lag. Please come to. Yeah, it's a 5%. Sorry. Aditya Kothawale, 5% of 0.06 means 0.003. Please come to live, because you are answering the answer of last question, Aditya. All right, so I would like to mention here, some of you may be new, so for them I'm telling you. Some of them may be new, so I'm telling you. If you have to give only one dimension of go and no-go gauge, see, go and no-go gauges will also have tolerances. Go and no-go gauges will also have tolerances. Tolerance means range. Tolerance means range. And tolerance always refers to a group. So there will be maximum or there will be minimum. Those who are not our regular batch student, please hear, please hear. Lot of question comes in GATE based on that. So in exam, if they are asking only one dimension, for example here, we have to give only one dimension of, go gauge and one dimension of no go gauge, correct? Lot of such question appears in GATE exam. We don't have to give range and maximum or minimum. If you have to give only one dimension, no, which dimension I will give, maximum or minimum? Can you tell me in the chat box? Because I want to make it sure that everybody understood, including my students of the regular batch. Please write in the chat box which dimension I will take, maximum or minimum. Please let me know in the chat box. Then only I will move forward. It's a serious business. And GATE many such questions. This is, by the way, GATE PYQ. This is GATE PYQ. I want to make sure this concept you have understood. I am reading the chat. Kushagra is always a champion. I am really very happy you understand and remember everything, whatever I taught you in the class. Rohan, it is, I think it is in the evening class, Rohan. But in 𝐂𝐚𝐿𝐴 Sir. My dear students, you have forgotten actually. See, now here, please don't forget. Okay, now that is the reason we are practicing some of the important questions again, that you don't forget. We are making sure that you are not mugging, you are understanding. Please do not have much poendi. Focus here. It's a shaft, and ISO gauge tolerances will be down. Suppose it is a hole. Suppose it's a hole. Then the tolerances will be here like this. Now this is the go, this is the no go. Minimum go, maximum go. Minimum no go, maximum no go. 𝐂𝐚𝐿𝐴 Sir, I think you were back. Okay, no problem. Tanmay, what you are, please repeat Q add. And I'm not able to understand, Tanmay, what you are asking. See, some of you are saying that I will choose minimum here. Correct, na? So this is the size of go gauge. This is the size of no go gauge. So you are selecting the minimum. Suppose if it is here, you have to give the size. You will say that I will select the maximum. Suppose if it is a workshop gauge. Okay, acha, okay, all right. Question was, Tanmay, the question is, acha, okay, all right, you have, Rohan is giving. Suppose, once again, one more suppose, if it is a workshop gauge. Suppose if it is a workshop gauge, then it's a hole, and this is the no-go gauge, and this is the go gauge. And now here, what go gauge dimensions I will give? This one means maximum. And what no go gauge dimensions I will give? This one, minimum. So most of your answers are wrong. I have dictated in your notes that for go and no go gauge, if only one dimension has to be given, we give that dimension where gauge tolerances are included. It can be maximum or it can be minimum. We give that dimension which includes the gauge tolerance. Remember, everyone? Everyone remember na? Please don't forget. All of you have worked hard for last 1 year, and we are already 1 month away from the final exam, and we are bringing the Maha Revision, Mahabhyas, and teachers are working hard. You are working hard. So hard work should be fruitful. Okay, but anyway, I am there. If there is any question, every Sunday 5 o'clock, Telegram. Okay, you can ask any question if any confusion is there. Okay, so answer is A. A, na? Yeah. Correct? Yeah, all of you are good. All of you are good. Yeah. Very good, very good. Very good, very good. Read it, let us see. Okay. Okay. महतो सिद्दीकी, नहीं माफ, महताब सिद्दीकी. That is a too basic. Mehtab Siddiqui, whatever you are asking, that's a too basic. That maximum material limit is go, minimum material limit is no go. I am discussing little more advanced in the last question. So, width is given 250 mm and 25 millimeter thick. Is to be reduced in a single pass in a too high rolling mill to a thickness of 20 mm. 20 mm. The roll radius is 500 mm and its speed is 30 meters per minute. So roll speed is 30 meters per minute. The work material has a strength coefficient of, so sigma F is equals to 240 epsilon raised to power 0.2 MPa. So we have to find out the power requirement in rolling operation. All the data is here. So epsilon is nothing but ln hi by hf, meaning ln 25 by 20. So sigma naught will be nothing but 240 epsilon 1 raised to power 0.2 divided by 1.2. Huda. No shape factor is given here. No shape factor is given. So force will be nothing but sigma naught W into L. W is given. L is equal to under root R delta H. Then torque F into L by 2 and the power will be 2T into omega. Omega means 2 pi n by 60. Roll velocity is given to you. VR basically pi d n by 60. We should not have 60 because meters per minute. So 30 means pi, diameter will be 1 meter, correct? No? Diameter is 1000 millimeter, means 1 meter into n. So n will be 30 by pi revolution per minute. Put it there. You will get omega. Find out this power. Everybody is okay? Don't directly multiply. We are like that. Calculate. Okay, 𝐁𝐚𝐿𝐴 Sir. But most of our answers are not coming out to be correct actually. 𝐁𝐚𝐿𝐴 Sir, what is your answer? It should be approximately 92.5 kilowatts. Little bit here and there is okay. You have to, Nitin, you have to multiply it by 2. Underworld Dawn, also he has to multiply it by 2. Okay, Lokhande. Venkata, Srivatsa, Srinivasa Venkata. Good. I think 92.0 is too far from range, I personally feel. We have to find out the total power. Per roll, it is never asked. Per roll, it is never asked in exam, especially GATE. We have to always give total, unless and until it is specifically given in the question per roll. Unless and until it is specifically given per roll. But that is very, very rare. I have never seen such question in GATE. You have to calculate the total power. You have to calculate the total power. Srinivasa Govinda. Yeah, it will be given. It will be given in NATs that question is requested in which unit. It will be given. Don't worry, it will be given. Rolling, you have to be serious actually. It was little disappointing for me that some of you could not give the correct answer. See, I will accept 92.3 to 92.4 to 92.6. In that range, I will accept. And rolling happens to be one of the most important section. Please don't do the mistake. Srinivasa Govinda, Sri Venkatesha Govinda. All right. Next. Think over it before hitting the answer. Please think over it. Don't be in rush. Don't be in rush to hit the answer. Don't be in rush. No, sometimes range is too short actually. You have to be a bit careful. You have to be a bit careful. Long Liangming. Liangming. You have to think little bit, na? Please read the question properly. Focus here. Focus here. Focus here. Manoj Kumar, Swastik, what you are doing? Nikhil murder. नहीं murder नहीं. Nikhil Kumar Dubey, not I said murder. Some of you are not, again, you are not, still not hearing. Still not hearing. Still not hearing. Focus on this. Think for 1 minute and focus on this point. This particular question is IES PYQ because these classes are meant for both GATE and IES. C. Cold forging results in improved quality due to which of the following? See, of course, in cold forging, there will be high pressure, but it is not contributing for improved quality. Na? There is no quality improvement because of high pressure. There is no quality improvement because of high pressure. Some of you may be thinking this unbroken. This first and third, everybody agrees that, everybody agrees that it's correct because why better mechanical properties? Dislocation multiplication. Correct? And why smoother finish you will get? Because in cold working, there is no oxide formation, so surfaces will be smooth. Very good, very good, very good. So the only dispute appears unbroken grain flow. I will give you some example. See, suppose you are cold working the materials where recrystallization temperature is the room temperature, lead, tin, zinc, all these materials. Then the grains will not be broken in that case. But of course, these are specific cases. Only point we can eliminate point 4 is, of course, in the cold working there will be heavy pressures, but it is not adding up any improvement in quality. Na? So remove 4. Very good. Some of you corrected. Swastik. Very good, very good. Okay, na? Okay, no problem. We do mistakes, no problem. But we should rectify from our mistakes. Yeah. What about this? It's an easy one. It's an easy one. Yeah. It's a pretty easy. No doubt about it. Pretty easy. No doubt about it. Huh? During Maharevision also, I have given this nomenclature. Very good, very good. Yeah, tell me about this. Think over it. Surface plate. This is the situation. L. Roll diameter is 25.4. And we have to measure 30 degree. This angle is 30 degree. This is L. Okay. Find out. Let us say this is H1. This is R. So this is also R. This is R. This is R. So H will be nothing but 76.2 plus H1. $203.2 mm. Good, good, good. All of you are okay? We'll wait for 30 more seconds. ओके ना, तोंदर काचे एंडी, चलो या दिस वन. चाहा पसंदी. Others, what they are thinking? I am seeing the answers of everyone here in the chat box. Others, what they are thinking, because there are varieties of answers available. Earring defect. Harsh, what is this? It appears because there are two anisotropy values, R bar and delta R. For any metal forming operation, we want high value of R bar that will increase formability. Delta R should be less because it will decrease earring. So anisotropy, variability in the material properties is the correct answer. Now, if the blank holding pressure is varying, what is the purpose of blank holding? To suppress wrinkling, correct? To suppress wrinkling. But suppose blank holding pressure is not applied uniformly. On one side it is more pressure, another side it is less pressure. So what will happen? That portion of material will flow more. So that side will, flow more thick. That will be thick, other side will be thin, so it will come little more. It's a earring, man. One side is flowing more, another side is restricted. So this height will be more, this height will be less. So blank holding. Same thing will happen with the clearance. How exactly we check the clearance between the punch and die? Clearance should be uniform. How exactly we check the clearance? By using feeler gauges. By using the feeler gauges. What are the feeler gauges? There are strips of different grades. So we insert the strip from all around to check whether clearance is uniform or no. Suppose one side clearance is less, one side clearance is more. So wherever there is a less clearance, there will be ironing. And due to ironing, deformation will be on the surface. It will have more height. This will have less height. That also leads to earache. For punch speed, there is no benefit. So I think it is good for the new students, correct na? It is very good for the new students. Some of you, I have already taught these things, but no problem, it's a revision. Many of you could not remember. So, bacho, best way to do all these questions, because evening 7 o'clock also there are more questions I will be doing. Best is don't have any notes in front of you. You can read the notes before the class. But when we start doing questions, you just see the question, remember and do it. That way you will benefit more. And I am giving explanation to most of the questions. Okay? No problem. I asked them. No problem, no problem. Very good. Chala bagundi. Very good, very good. Read it, read it, read it. Very good, very good. I think this everybody understood. This everybody understood. Hydrostatic extrusion. It is suitable for high strength superalloys. The billet inserted in the extrusion chamber where it is surrounded by a suitable liquid. The billet is extruded through a die by applying pressure. Correct. It is meant for brittle materials. As I told you when I was teaching this in the class, I told you that some Indian authors, they say cracks are getting closed. No, that is not the answer. It increases ductility, because in the hydrostatic component increases for 1 Meissner cylinder. Deviator component, there is no change. I explained this during the class. Okay, so very good, very good, very good. What about this Tondrakachhe Endi, this one? Telugu is an easy language, everybody should learn. Especially from North India, it's an easy language. 2-3 months it can be learned, at least workable Telugu. Entrance angle is semi-diangle only alpha. Because friction is given to you and no empirical formula is given. So sigma D will be nothing but sigma naught 1 plus B by B 1 minus A by AI raised to power b, and b is equals to mu cot alpha. Elastic plastic, so this will be sigma naught, and it's a wire drawing operation. Draft is 15. Draft is nothing but di minus df. So 15 is nothing but 90 minus df, 75 mm. So force will be nothing but sigma d into af. Af is pi by 4, 75 square, and power is nothing but f into v. Easy one, na? So no empirical formula is given and the friction is given. It means we have to apply the slab method. We have to apply the slab method. Sundar ka Chendi, quickly, give me the answer quickly. Kushragra and Rohan getting some answer. Is that okay? Very good. Okay. This is good question. This is good question, and I have discussed during the workbook discussion. Please don't, keep the book open. Please don't keep the book or this thing open directly to the questions. Otherwise, benefit will not be there much. Based on what a Maharevision and whatever I taught you, based on that memory, you try to do this question. Everybody B. By looking at each other. Yeah, at least some people are there. See, the material properties which principally determine how well a metal will be drawn means permeability, means permeability. Materials permeability will be better, when materials permeability will be better. It primarily depends upon two factors. First is R bar and the second is the work hardening exponent. Please hear carefully because some of you messed up this question. Not some, many of you messed up this question. At the end, I will ask you how many people, how many of you give the correct answer to me, okay? Na? So, work hardening exponent, suppose if it is high, it will suppress the formation of neck at the punch corner radius. There is a necking, na? And the necking leads to fracture. Necking leads to fracture. Suppose work hardening exponent is high. Suppose the work hardening exponent is high. The moment due to necking, fracture is about to appear, it will suppress it. So permeability will be better. Some people think that it is ductility. Yeah, ductility plays a part, but not much. Because aluminum is ductile, but it is not at all permeable. Because its N value is very low. N value is very low. So, all of you are agreeing point number 2 and 3. See, number 1 is also okay. Ratio of yield strength to unfemoral tensile strength. This ratio also decides what will be the value of N. Suppose UTS to YS ratio is high, it means N value will also be high. It's an indirect indication. Or let us say YS by UTS is low, N will be high. Directly it tells you what will be the work hardening exponent. So it goes, certainly ductility is important, but ductility is not all in all. Permeability is primarily decided by these two factors. Answer is D. By the way, one person, na, because I do this hand movement and all that. Na? Because it's a YouTubers are very popular. Funny student. After the class, I was very tired because almost 7 hours na, from Mahavya. One person sent a message to me. Personal telegram, I don't read too many personal messages to you. I don't have time. He once said, sir, there is one popular YouTuber who basically hand movement like this. You are also doing like this. No, I have not seen him actually. My God. I think, YouTubers are very popular in India. You can do anything and get popular. You criticize somebody, some popular leader, and you will become very popular. It's a trick. Okay. What is the answer for this? No problem, Tanva. That's the reason I'm here to support you. I'm there. Any question at any time, I'm there. So we are here to refresh all the fundamentals. All the fundamentals. Don't worry. Be happy. Okay. Good, good, good. Here, there is no confusion. Can you ask me later on this one? Vibhu? Yeah, B is the correct answer. So I hope no explanation is required because all of you did correctly. Very good, very good, very good. What about this? What about this? It's an easy question now. Easy question. Don't do mistakes. That na IES means crystal direction question I will do at the end. Very good. It's annealing. All of you are correct. I'm happy. See, if some explanation is required, please let me know. I'm happy that you are able to do it. Annealing. Very good. It's a correct answer. Okay, good, good, good. What about this? What about this? It's easy. I'm happy that you remember all these things. I'm really very happy. Tanma, you can say like this. Resultant microstructure for most of the annealing will be parallite only. Most of. Okay. Okay, no problem. Sometimes it happens. Our typing people, he is also having a lot of load now. Sometimes mistake do happen. Quickly, here the time matters. Because you know everything, here the time matters. Who will do Tundaraka Cheyandi? That is only different. So Joy, good to see you. I think you joined late. Correct, huh? You joined late. All the 4 reactions. And you know, we had a detailed discussion on these things. Still some of you are taking too much time. You should not take too much time in this question. Yeah, good. It's a D. Because for explanation is not required in this particular question. Correct, na? Explanation is not required in this question. It's an easy one. It's an easy case. Yeah, what about this? What about this? Quickly. I want answer. Quickly. Don't see here and there. Give me the answer. Still answer is wrong. See, when the Chorinov index is not given to you, by default take 2. Okay? So K is 4 minute divided by centimeter square. Alright? So volume by surface area is nothing but 30 into 10 by 2 divided by, this also convert into centimeter, na? because everything is centimeter. 2 into 30 into 10 plus 10 into 2 plus 2 into 30. Find out T. So these questions now, in GATE, you have to do the calculation pretty fast. Casting these sorts of problems, they are pretty easy. But in GATE, actually, you will have less time. And there are heavy calculations involved. So you have to practice. Rohan. The point is why I'm adding these questions, although questions are easy, because they are a calculation. We should be practicing well. Fast calculation and not doing any mistake. You cannot take more than 3 minutes in any question. 2 marks, lengthy calculation, you cannot take more than 3 minutes in GATE. What about this? It's a vertical centrifugal casting. Vertical centrifugal casting. Like this. We are rotating about this axis. Radius at top, radius at bottom, and L is the length. Vertical centrifugal casting. $2.5 minutes. Tanmay Bari. Yeah, that is the reason, na? Harsh. We have to practice, practice, practice. Whatever you have already done, practice that rather than seeing the new topics again. Practice, practice, practice. Thickness in millimeters. So N is equals to 30 by pi under 2GL divided by RT square minus RB square. No problem, Tanmay. Everybody do mistakes. No problem at all. No problem at all. What is the answer now? For that reason, we are practicing multiple questions. The evening, there are little more difficult questions. Some new questions that I developed. Evening batch, there are a little bit more difficult questions. English channel, there are 21 questions only. Questions are a little easier. Evening, little more difficult questions. We will practice 7 o'clock Hindi channel. English channel, I wanted to take it little easy. Give me the correct answer. Tundaraka Chendi. Swastik Damodar. Getting one answer? We have to do little fast actually. Because gate is only 1 month away. We have to increase the calculation speed. How? By practicing more and more such problems. Calculation should be fast. And best will be to use gate calculator. The way the calculator is given in gate. The same way. Same calculator, try to use it. Evening we will be doing more than 30 questions now. But I insist to all of you to use the gate calculator. And there will be many problems. I don't use this calculator that na our scientific calculator, don't use that. Whatever calculator provided in gate, that calculator you should use it. It is asking diameter dt. dt means 2 RT. Evening use the gate calculator only. Don't keep shortcuts. Otherwise there is no use. I don't think basically some of the answers are not coming as per mine. Solubility, Durga, just after this question, which question you are talking about, solubility? After this question, somehow this answer is not matching with mine actually, I don't know. This answer is not matching with mine. Durga is telling something. I will go to previous question after this answer. After this answer, mostly if you are getting 185 actually. My answer was 168 actually. I don't know how. Maybe I may be wrong. 168 mm, but please check. Please check this answer. Durga, on the request of Durga, I am going little back. So, about the solubility, isomorphous system is 3. Two metals are completely soluble in liquid state and completely insoluble in the solid state. It's a eutectic system. Yeah, completely. You are correct. Durga, you are correct. Rest everything. No. Two metals soluble in liquid and solid state. Let us say A is to 4. Okay, na? Eutectic system. Let us say B is to 3. Peritectic system. C is to 1. Monotectic system. Actually, it should be like this. So you are correct. 4, 3, 1, 2. See, eutectic systems are of two types basically. One liquid are partially soluble in the liquid and solid state, and one liquid is completely insoluble in the solid and liquid state. We do this, na? We do the thanks, Durga. A plus B liquid, and here's the activity point. I told you bismuth. Bismuth. Okay. No problem, no problem. So 4-3, change it. Then D. All right. Because binary phase diagrams are two types, three types. Bismuth, bismuth is the third category. Two materials completely soluble in the liquid state and completely insoluble in the solid state. That is also a eutectic system, but category 3. Category 2 is a partially soluble. Category 1 is completely soluble. Correct? Very good, very good. See, peritectic system. You are correct, actually. Anyway, these options are not correct. You are correct. 100% correct. Options is not correct. So, A is to 4, B is to 3. Peritectic system. One liquid and one solid combines to form a new solid. 2, 3. Yeah, this is the thing. Actually. You are correct. You are correct. Marks to all. You are correct. Rohan, marks to all. Marks to all. Good, good. Good, good, good. Yeah, what about this? What about this? What about this? It's an easy one. This is the easy one. Easy one. Don't do mistakes. Easy one. Yeah, very good, very good. See, you know why? It's very easy. First statement is wrong. When the liquid metal enters into the mold cavity with as high speed as possible, it leads to turbulence. Sand will be eroded. And that produces pellite. So first is wrong. All right, very good, very good. What about this? It's an easy one. This is also easy one. I want quick answer. Very quick answer. Quickly, Sundar ka Chendi. G factor is the centrifugal force divided by gravity force. Mr omega square divided by mg. Mm cancels out. R omega square divided by G. And omega, everything you know, G. If it's a centimeter, you can say G is nothing but, you say 9.81 meter per second square. Na? So you can say 981 centimeter per second square. Because unit should match. Unit should match. Yeah, 83.8. Can you tell me to avoid rain? To avoid rain and excusing G factor should be in what range? Tell me quickly in the chat box. It should be between 60 to 120, correct? To avoid rain or squeezing, the G factor should be between 60 to 120, correct answer. Correct answer. Okay, very good, very good. What about this? Yeah, it is always the outer radius. In one of the Indian author book, they say mean, but no, answer in the gate comes only by outer radius. We have to see the false statement. Among these, which statement is false? Which statement is false? Some of you are clean bold here. Some of you are clean bold here. No problem. Take time. Take 1 more minute. Take time. Many of you are getting clean bold. Some of you are saying D by looking at others. Some of the things are statements are pretty easy. Some of the statements are pretty easy. Chudandi. An oversized solute atom would preferentially migrate below the plane of edge dislocation. Because below the plane, there are tensile strength region. Because there is a little more space. So oversized pattern will try to fit there only because the space is slightly more. It's a correct statement. Now, just a minute. Vacancies are attracted towards the compressive stress region. That is also correct statement. Compressive stress region, what is the meaning of that? What is the meaning of that? Impurity atom size is bigger. They're feeling very uncomfortable. From all the sides, the atoms are getting pushed. Correct, na? That is the compressive strength field. So it will be attracted towards vacancies. It will be attracted towards vacancies because the bigger atom will be more comfortable because space is more. So it's a correct statement. I don't know why you have put T. It is asking false statement, na? If you are my regular student, I have shown you the video also. 4 videos. Okay. Now, a point defect can locally modify the elastic modulus and thereby can change the interaction energy. It's a 100% correct statement. You know why? You know why? What exactly is the elastic modulus and the elastic region? And we will say that the elastic region is over. When exactly we will say that your elastic region is over? When applied stresses reaches the critically resolved shear stresses, so dislocation begins to move. But if there are dislocation is a line, so entire line is moving. Now, when there is a point defect, it can be either vacancy, interstices, substitutional. All these point defects creates a strained field in the host atom. And these strained fields creates obstacles in the movement of dislocation. Yes. So dislocation is not able to move. So elastic region will be modified. So this also statement is correct. This statement is wrong. So Rohan was correct actually. He's a brilliant boy. Anyway. Spherically symmetric point defects can interact with both the hydrostatic. See, if the symmetry is there, size, everything is same, it will not have any effect. So B statement is wrong. He was correct. B statement is only false. All of you got clean bold here in this question. No problem, no problem. I'm here to explain. Yeah. Do it. Do this. Do this. Do this. But I was expecting that some of you will hit it. I was really expecting that some of you will hit it correctly. A tensile test is performed on a metal specimen and it is found that the true plastic strain is 𝐂𝐚𝐿 and it's produced when true stress is 575 MPa for the same material. So here 575 K value is given to you 860.2 raised to power, and you can find out that. Now it's a case 2. So when the true stress is 600 MPa, find out that. There is nothing in this question, only little twisting of words, that's it. Only little twisting of words. Nitin, Manoj, very good. Actually, some kind of, whenever my feedback, some heart symbol, these things are coming automatically. Why? You are doing something or no? Some symbol, heart symbols are coming out from wherever one of the feedback is there. Naturally, YouTube I also opened. Lot of symbols are coming out. You are doing something or it is coming automatically? Huh? Someone is doing that. Who is doing? Suppose you do, then what happens? You try to do some symbol, let us say heart symbol. Heart symbol. Yeah, 0.237 is the correct answer. I see. A reaction button. This YouTube, I don't know much H to be frank with you. Okay. Now, all right, my dear students, everything is okay. Now let us do it. The question IES means 2025. Now it disappeared. It disappeared from. And directions were given. It's my regular their notes where I've written where I have to teach what. Okay, na? What are the You can say mirror indices of directions ABC. So, it was given origin is here, x-axis, y-axis and z-axis. So, finding out for A, it is 1, 0, 0. There is no problem. 1, 0, 0, no problem. And direction B is also starting from the same position. So B also there is no problem. It is 1, 1, 1. We have to find out for C what are the Miller indices. Do it. Do it. Do it. Do it. It's a mains question. It's a mains question. Yeah, please do quickly. See, direction should start from the origin. Because the direction is starting from here, we need to shift my origin. So presently origin is here. You shift the origin to here, this place. Either you can follow the right hand thumb rule, otherwise let us say x prime, y prime and z prime. Okay? Alright. Durga, we don't say fractions. We never say fractions here. So now, so here, what is the coordinate corresponding to this origin? What is the coordinate of this point? X. So x is minus half. Correct, na? Plus x minus x. So x minus half. Y is minus 1. Correct, na? Plus y minus 1. And the z is plus 1. So the coordinate is this. So minus 1 by 2, minus 1 and 1 multiplied by 2, minus 1, minus 2, 2. So 1 bar, 2 bar, 2. Is that okay with everyone? Yeah, very good, very good. Some of you are doing really very well. Some of you are doing really very well. Think over it. This is the last year IES mains, most recent one. So that's what for this English batch. 7 p.m. for Hindi YouTube channel. Again, I will be back with more questions, more than 30. Thank you very much and good day to all of you.